Okay, science notebook. Everyone take out your science notebook. Science notebook, okay? You don't need anything else out, just your science notebook. So anything else, make sure that you're writing utensil in your science notebook. Okay? Try to be quick because we don't have a lot of time. Okay. Anthony, science notebook.
There's someone up there.
Okay, that's okay. I'll get it. Okay, so we are following up what we were doing the other day. So remember we started the new beginning of class 7. So instead of just doing our getting started questions, we added in last week that we would do the questions, we'd work on them independently, and then you'd have an opportunity where you would share with your classmate, and then we do a group share, and then we move on. Okay, so today is going to be the same. Now this is a 2-part experiment. We're going to do one part of it today. We'll do the next part tomorrow, just so we can allow time for the questions and the think, pair, share. So let's make sure that right when you get them, immediately on your next available notebook page, which is what page? Let's see.
23.
Okay. So on page 23, you're going to copy. It says it right in the top. Please copy and answer these in your notebook. There are 3 questions. Silence, by yourself. After about 7 minutes, or when I notice that everyone's done, we'll have an opportunity to share, okay? We're going to do part 1 of the procedure of the lab afterwards, but that's on until we answer the questions and we do our think, pair, share, okay? So when you get the paper, immediately start copying them down so that we don't lose a lot of time on that aspect.
Copy the questions down?
Yep, copy and then answer them. 19. Boys, this is no conversation. We need to be quick in, okay? So, right. Let's get some questions. Yeah. Okay, at this point, can everyone find who you know you're sharing with, find your partner, and I want you to share your answers. You've got 5 minutes to share your answers that you each got, okay?
Let me see. This is what Bella said.
Okay, so let's talk about what we got for answers quickly so we can go on to this part 1 of the lab. All right, what evidence do we need as scientists that a chemical change has taken place? Use examples to support your thoughts. Okay,
I have,
that's great, what do you like to yell out?
A new form,
A new form, what do you mean by that?
changes, mass maybe, changes.
Oh, the mass change, that's an interesting thought, okay, we'll get back to that.
I said like certain effects will happen.
Okay, what kind of
Like bubbliness, temperature change.
bubbliness, temperature change, okay, Max?
It can't go back to its original form.
It can't go back, is that what you said? Okay.
Statement number 2.
Okay, but I'm still on 1.
Color change.
Alright, color change is another one. You just put it on the back table there. Okay, second one. Do you think there'll be more, less, or the same amount of stuff or mass after a reaction occurs? What are your thoughts on this, Kayla?
Chemical change.
You know, why will it stay the same? What do you think? Okay, it's changing its form, it's not changing its weight. Mia?
Okay, I said that there would be less because like when it starts to like have this reaction, it's gonna like disintegrate.
Okay, when it starts to, it's going to disintegrate, so you think the mass is going to be less. Richie, what did you think?
I think it'll be the same.
Maybe the same? Okay, any different reasoning than Kayla? Okay, number 2. Max?
I think there will be less due to the increase in temperature.
Okay, you think there'll be less due to the increase in temperature, so why would the increase in temperature?
Why would it? Because it's bubbling and fizzing.
Because what?
Because when it bubbles and fizzles,
When it bubbles and fizzes, that increases temperature?
Gas.
It releases gas. We have different things, we're talking about different things. Talking about temperature, talking about gas. You said something about that didn't happen. What didn't happen?
The ice cube yesterday.
Okay, so that was a physical, we were doing a physical change of the ice cube, you're right. It didn't change its mass, okay?
Depends if air enters.
Depends if air enters, that's an interesting concept.
Depending on the 2 substances that
Cool, so it depends on the substances. Okay, well, let's go on to the third question. Imagine that one of the products' reaction is a gas. So you have a reaction and gas is a product. Is that going to affect with the mass? Well, how will the mass change if one of the products is a gas? So think about when we did this mystery mixture project in the beginning of the year, and it bubbled and gas was released. We talked about what gas that was. If I were to weigh those things, would it change?
I said yes.
You say yes? What do you mean?
It will change, the mass.
In what way?
I don't know, gas, make the things, make them more,
Okay, so gas is released. How would that affect the mass?
get lighting, maybe?
Okay, get lighter maybe. We're not sure. I mean, what is gas? Does it have a lot of mass? That's what we have to. Never mind. Okay. All right. So today's experiment is really looking at understanding about mass and will it change. We know we proved on Friday that with a physical change, the mass didn't change. Correct? Right. So now with the chemical change, does that same thing occur? There's 2 parts to this. So we're going to do one part, and then we're going to answer some questions and talk about that. And then the second part we'll do tomorrow, just because of time, and we don't have enough time to go for Monday and really dive into the questions. So,
I don't have time.
a couple things that I want to point out. We have, what's up? Wait a second. We have only 3 balances, okay? I only have 3 balances. I strategically placed them on the lab tables because they're solid, they're stable, they're better for balancing. That's why they're there. Table uses it, but then we're gonna have to split up and share other tables that will use it as well, okay? So we're gonna be in 6 groups, so that way 2 groups will use each balance, okay, to measure. Now, I also want to point out a couple of different things. When I pass things out, I pass out containers, and Kayla nicely lined them up here. They're both labeled. You have citric acid and sodium bicarbonate. And I want to point out that the spoons are also labeled. Why did I do that? Why is that important?
So you don't mix it.
Yeah, you don't want to cross-contaminate, right? We don't want one to affect the other. And I apologize for this, but I could not really, with my large marker, write sodium bicarbonate on this small little label, so I wrote the actual chemical formula on there. So know that that is the same thing. You should know that one anyway. You have a graduated cylinder. That is to measure out the water. In a minute, I will walk around and give you a cup of water. You have the 2 cups. These are the cups that you will be using, okay? So when you follow the directions, you'll notice I'll ask for 1 cup for the mixture. There is a small change here. I did something to help you, just because I didn't want to have you measuring out by grams, I think this, each substance, and then trying to do it. So instead what I did is this morning, I went ahead and I actually figured out that 1 level spoonful of this is about 3 grams, which is what I wanted you to use, okay? So we're just gonna use 1 spoonful of each and go from there, okay? And then everything else should be pretty self-explanatory. Make sure you follow the directions. I wanna point out that if you flip over the paper, there is a data table. Now, let me finish, Sharon. On the data table, I have combined experiment 1 and experiment 2. Are we doing experiment 2 today?
No.
No, we're only doing 1. So that bottom half of the table, you're not even gonna look at. So in the first half, you're gonna see experiment 1, it says cup with 3 grams of, and that's citric acid, because I didn't write that out, and 3 grams of sodium bicarbonate and 10 milliliters of water. So, and what is the mass of that? So you're gonna have 2 different cups, and you're gonna find out, obviously, the mass before you mix them, right? So here's your citric acid and sodium bicarbonate, and here's your 10 milliliters of water. You'll find the mass. When you find the mass, which one do you think you start with on the balance? Do you remember?
The big one.
Well, we would, you're right. We would start with the biggest one first, but I know for a fact that it's not going to be that light, so we're more likely going to start with this back one. And we'll go over, and if it gets to the point that it's too heavy, we know that we've gone too far, and then we go to the front one, okay? So once you've measured that, you have a beginning measure. Make sure you record it, and then write any observations. The second one is that you're actually going to mix them. So if you go to the procedure, you're going to take the water, and you're going to pour it into where your mixture was. We did this in the beginning of the year, right? A reaction is going to occur. Kind of swish it around gently. Once that reaction is complete, you're going to take the combination of all 3, but you still have to put this, why do you still have to put the 70 cup on there?
To see what the mass is.
Why is it important that I put this back on here?
Because you waited with the water.
I waited with the water, so I can't, that's going to affect it if I don't have it there. So I need to put that there. And then we're going to find the mass afterwards, okay? And then we're going to have some discussions about it, and that's all we'll do today. And then tomorrow we'll do the remaining part, which is the next experiment, okay? So I am going to let you read the procedure at your tables. I'm going to move people around. I'm going to have Isabella come up here. I'm going to have Anthony turn around there. I'm going to have James come over here, and I think that'll be good, okay? And everybody else, I am going to have you read the experiment, and I'll walk around with water so you can get started. And I'm trusting, you don't have a lot of time, so I'm trusting that you will be a good self-starter.
Yo, James, you want that?
Hey, honey, where'd you put that water that I actually get? Oh. Now. No, I need to put it in the cup that I seem to misplace too.
Is that a Cheerio? Is that a Cheerio listing?
Okay, please don't do that.
Sorry, Cheerio. It's a Cheerio. Not Cheerio. I did not send the law said. Okay. Wait, one more thing.
What are we forgetting?
So we need goggles, miss.
Oh, who just said that?
I said it.
I thought that
Excellent. Richie, grab a box and walk around and hand out one goggle per person. I'm very proud of you, but we are going to lower our volume again and get to work. Do not do any combining of anything until you have your goggles. Yes, follow the directions. Somebody needs to be a group leader. Who's going to read and give you a director? All right. Okay, that's it. Richie, we don't have time to play around. This needs to be on paper to start. Okay. Now, let's get started. So read the procedure. We're on procedure 1. First thing you do is so 3 grams is 1 scoop, okay? Are you gonna put the water there? Okay, remember 3 grams is 1 scoop. 1 scoop. Yeah, 1 full scoop. No, you're putting them in the start cup. This is to measure the water. Alright, so you don't need this water anymore. That's just 1 scoop. Okay? Yeah? You have a cup for water. That's not 10 milliliters. No, right? Because you use substances yet. All substances will go in line, and then the water. I know. 1 to 2 will be 3 grams for this lab, okay? Yeah, so, well, yeah, you put the same one. So, he already put it in there. The other cups. Okay? Okay, so you're putting both substances in 1 cup and then the water too. Okay, now you cross-contaminate, so now that you mixed it, you're going to have this now. All you had to do is do this. Okay, so now it's water, cover that, take this out. Make sure you cover your materials afterwards. The citric acid can't be exposed to the air too long.
Water into a cup. 10 milliliters of water into a cup.
Into a different cup. Yeah, just put it into, you don't want them to react, you want to put them on there without water. I'm very excited about this.
I'm sorry.
I can tell.
Get ready, my video.
So you need to get, so what you're going to do is when you're ready, one of you needs to come over and go use the balance, okay? So, you're going to have to share a balance, so when you're ready, if you don't have a balance, you just need to go to a table that has one and use it.
10 milliliters in water. Place 2 cups of egg.
That's too much, so I'm burning that down. Okay, so. Perfect. Unless it goes beyond, actually.
Take your paper.
So, there you go. So, if it was going down below that, you would have to just and then work your way up, okay? Watch out,
Down.
Okay, I see. Who needs more cups? There we go, something. Aja? That's for your group. Meeting what works. Leave your meeting. Okay. Who need, Fernanda, you need new cups? Fernanda, you need new cups?
I do.
Do you have a couple
Yeah.
of this?
I don't, you probably only need one, right?
I thought you guys were not on some cups on me. Yeah.
Your own. Miss, I found it.
Let me see.
Perfect. Well,
Okay, you can't put it between there. So you have to use it. So like, it's 20 is too big, so it's 10, right? But now this is fine, so you know it's fine, all the things you slide that over.
oh, sorry. Oh, it smells like mint.
Jason, please.
Okay?
Oh, it's good. Right.
Okay?
Oh, right there. Right there. Too much. Because I just want to double.
Like coffee.
That's what I
Okay, so it would be, well, it would be 2.5. Now, wait a second. No, you gotta do it again. Here. All right, you guys were, it has to be on, it has 10, so it's not 12.
Are you guys done?
Now,
Is that how you write it?
Okay, it's 15 and up.
We're going to
Yeah. Yeah.
16.1, you did.
There's nothing
Okay, once you weigh it and you record the mass, you can actually pour the water into the mixture and have it react. Okay, once you recorded the mass in your data table. What is the unit for mass? Is it just 15? 15 grams. Make sure you write the unit. If you're gonna fight over it, then you're gonna make a mess. Okay? Well, we already know, right? The waste of reaction is complete.
No, it's not complete.
Okay, just give it another minute to kind of. And it's not bubbling anymore. Max, what group were you with?
I'm no Sarah.
Oh, they erased it.
Okay. You were there a second ago, and I was like, okay. So what did you react to, right?
Just to say.
Anyway, it's done reacting. Okay, so you now you write down grams, takes like grams, and you already measured it afterwards, and it's 16.1. All right, observations, right? Observations there. Okay. I will know that you're done when you are sitting down quietly at your table.
Yes, you are.
It's a small one.
You are going to answer just question one. Have you done the after yet? The after reaction?
I did.
Are you done? Did you get your final mass?
It's online.
Okay, so you're still, wait a second. What is the mass here? What was the mass?
I know one is 20. Both the cups.
You're down for everybody else?
Yeah.
Because this class is called for.
Oh, okay.
Knock, knock.
Please come in and sit down quietly. Remove your hooded sweatshirt.
Uno, dos.
Yay, my chair.
Remember that
Where's the
today,
chair? My chair.
your chair, oh, it's over here. Just grab it.
Oh.
Yeah. Please come in and sit down quietly. Take out your science notebook and your science, those lab papers, okay? Yep, you're coming in silently. No, we don't have time. Coming in silently. Take off your hooded sweatshirt.
I thought I did sanitation.
Okay. Take off your hooded sweatshirt, sit down, take out your science notebook, not a sound, please. Immediately, this is the question, it's gonna come up here. This was the question that you answered. I know it's been a few days now, because we had the weekend in between. But your post-lab question, I don't understand why we can't sit and take off our sweatshirts. We don't need to be standing. The post-lab question from that first lab was on that sheet. Should still be in your folder, okay? So the things that you need to have out on your table right now are this lab sheet, Some Things Never Change, Part 2. Okay, that paper should be out. And the paper that says post-lab questions, which number 1 you answered, it's the one that's on the board right there. And then your science notebook should be out. So those 3 things should be out and everything else should be away.
What about this?
I held that up first, okay? We'll keep it on time.
We need this.
Yep, you need the, no, is that the ice one?
I don't know. It's not plastic.
Yeah, put that one away. Okay, quickly before we get started, I know this is off subject, but I want to do this because I fear I'll forget at the end. Those of you that need to finish your civics homework, classwork, excuse me, and needed a copy of the reading from the book, can you raise your hand? Let me just hand that out, put that right away. So this is a copy of the reading for you to finish your civics classwork. You're done with everything, Max? This was those reading notes. If you finished it during class, you don't need one. But if you want to make it better, or you didn't finish it during class, I made copies of the reading for you. How are you? Such base as you, I have to videotape this last thing, so. Pretty simple. If for some reason you cannot find, we're going to start class with this, and it's silent individual work. If for some reason you cannot find that post-lab work that you did, this question, you should have it. It should be in your folder, as I told you. And you should have already answered it. But you know what I'm going to do? Because it's been a little bit. Yep. I'm going to give you 2 minutes. That's it. 2 quiet minutes to take a look at the question again. Make sure that your answer is what you want it to be. And if you didn't answer it the first time because you were absent, then you can answer it right now on a separate piece of paper, okay? 2 minutes, no discussion, before we have time to share with each other, okay? Then just, what do you think? Okay? Yes, ma'am. It's probably the same one, it's in the original. Oh. Okay, so I just said that this is 2 quiet minutes. The only voice I should hear is mine. Nobody else's.
Or we looking things.
One more minute.
Should we keep this?
Okay, now I'm going to ask you to turn and share. So we're doing a pink pair share again. Turn and talk with the person next to you if you're in a group of 3. Turn and talk to the person behind you that has that extra third, okay? So everyone, you have 2 minutes to share your answers and thoughts. So you guys.
I said no.
I was explaining to her what
James? No, Anthony, you're sharing with Kevin. That's okay, you can explain to her, go back to your seat. And James, that's fine if you share with Jared, but you need to,
We did a different one where it's explained thoroughly. I'll tell you what happened. Back to your seat. Actually, explain to her. I'll tell I said, I think actually they're added.
We're done.
James, I thought you were sharing with Jared.
Because we're doing all that.
I hope so. Yes. Okay.
tell you what happened.
Okay, so let's hear from some people. I did walk around and caught some of the conversations, although it was a little bit louder than the first time we did this, and it cannot be that loud. You are literally carrying, and I don't want anyone getting out of their seats, so we're gonna have to figure out the way the seats are working. I know that I have you in 3 just because of the size of the room, but we're gonna have to figure it out because it's too loud and we shouldn't have anybody getting there. Maybe we just talk as, instead of a pair, we just do as a group of 3, okay? So let me hear from some people as a group. What did you notice about the mass of the cups before mixing the water with the solids and after? Okay?
It weighed more after?
It weighed more after.
Yeah.
Okay?
Not really.
Look at the data. Somebody look at the data. Did it weigh more before or after?
Before.
Okay,
I made that.
why, James, explain to me, what was your weight before?
Huh?
What was your weight before?
18.
18 grams. And what was your weight afterwards?
16.1.
16.1, okay. Another group, did you have a similar result?
We had 14.5.
Yeah. For the experiment one,
Yep, could you tell me what your weight was before?
16.2,
And what was it afterwards?
15.6.
Okay, so yours went down too.
Ours
Was that,
The fist, makes the fist change.
say it again?
That's when we, got the sodium and the acids together.
Okay, did you expect that to happen?
I thought we had, if the gas got released, then the mass changed.
Okay. Did you guys hear what Zion said?
Yes.
Could you say it a little louder?
When it was fizzing, maybe the gas was released and the mass changed.
Okay, so maybe when it was fizzing gas was released, it would change. How many of you who else wants to add upon what Zion said? You want to add different, you can add different, right?
Ours was 20, the mass, but then it changed to 18.4, so it lost like 1.6.
Okay. 2.6. So it started at 20, it went to 18.4, lost 1.6 grams. What is your reasoning behind that, of losing mass?
Same thing with the gas.
6.
Or I mean,
17.
the zinc or the
Yep. So when we did the ice cube lab, that was the first demo that I did. When we did the ice cube, did the mass change before and after?
No, it kind of stayed the same.
It stayed the same. I think it was 0.1 off, and there could have been various reasons why. We talked about the reasons why. But the mass stayed the same. And you guys all thought that. You said, well, it's just a solid piece of ice turning to liquid water, and even though it underwent a change, you thought that the mass wouldn't change. You all predicted that. You did a great job. But then we talked about the fact that, what kind of change was that?
Physical.
Yeah.
A physical change, right? Why was it a physical change?
Because nothing, it didn't freeze, it didn't bubble, it didn't like this.
Yeah, those are some of our indicators. You heard it didn't fizz, didn't bubble, color change, temperature change. It was a physical change. So this one, what kind of change was this experiment?
Chemical.
Okay, why is it chemical? Somebody else I haven't heard from. Why is it chemical? Sarah? No? I've heard from Zion, somebody else. Why was this change in this lab or experiment a chemical change? How do we know? What do you mean a reaction? It fizzed, it bubbled, right? So those were some indications that there was. What else did you notice? Was there any other observations that you made about when that reaction happened? Yes. Temperature change. What did it feel like?
It became colder.
It got cold. Okay. What kind of reaction is that? Anyone remember from our notes?
Temperature change.
What is it called when it gets colder? Endothermic reaction. Good job. So we had this experiment. And now this time, because it was a chemical reaction, we had a loss of mass. But Zion and Aya also agreed, and I think some other groups as they were talking, was that, well, maybe it's because gas was released. So what if we did a third experiment now? How could we check this to see if that's true? What is another experiment that we could do?
What would you say procedure?
All right, let me get Caleb now.
We can cover the top so the mass is released.
Okay, we could somehow cover the top so nothing could escape. All right. So that's actually what I had planned for today, okay? Are the few boys ready to keep going? Are we good?
Yes.
Okay. So, same materials, and I think I already showed you this procedure last week, but I just want to give you a refresher. I have your sodium bicarbonate here, and your spoon, your scoop that goes with it. I have your citric acid, your scoop that goes with it. You need the water, that's what makes that reaction start. I also realized that I had additional balances in the room. Besides the triple beam balance, I have a couple of these other ones. These need to be plugged in, but, and I don't know how that's gonna work with the configuration of the room.
There's no outlet inside.
Yeah, there's not a lot of outlets, but at least we can move it up to having 5 balances and only 1 or 2 groups have to share. So we'll figure that out. We have the cups. The paper cup is really just to mix the 2 scoops to get started, so you have that dry, solid mixture. And then the additional thing is we have the Ziploc bag. So if you remember when I gave you, I'll show you again how I want this done, because we just have to be very meticulous, because we don't want our reaction to start before it's supposed to, because that would affect the results. So every group's gonna need 1 Ziploc bag and 2 rubber bands. And remember how I showed you to do this before, is that when you have your mixture, when you have the mixture in here of sodium bicarbonate and citric acid, if you put it like this, you could really get it right in that corner, and then kind of rubber band it up, okay? Go around as many times as you can to kind of get a secure fit. And then with the water, another material that you have is a graduated cylinder. When you pour the water in here, now going to the other side, you want to be very careful that you kind of pour it in there, and again, keep that water separate. Once they're separate in here, you're going to find its weight, okay? So you'll make sure also, make sure that you Ziploc that. You want to get that close, okay? Put it on the scale, find its initial weight, record it on your data table. Then you'll gently release the rubber bands. Don't try to just pull them off. You'll have to kind of undo a couple times, because then you'll rip the bag. And then you can gently let them mix. They'll react. Wait till that reaction is complete. How do you know the reaction is complete? When it stops.
Fizzing.
Thank you. Fizzing, bubbling. Okay? When you think it's complete, any observations you want to make, write them down on the chart, and then you're going to reweigh this. Okay? Once you're done with that, I'll walk around, and these bags can actually, once you're done filling out your data table, making your observations, with the bags remaining closed, you can actually discard them in the trash, and then you're going to go answer the rest of those questions, post-slide questions 2 through 5. Okay?
Okay.
I need you to, as quietly as possible, go to your lab groups from the other day and have a seat. Once Anthony sits down, we'll get going, okay? You don't want to have, you have way too much on the table here, you want a workspace. Make sure, I will walk around and bring you a balance, okay? I'll walk around and bring you a balance. If you can do me a favor, choose 1 person from your table to your
Also, you have to get up and look at the material. Because they're just bending.
such a great job on my video. That's what's our some of these lab sheets are
This
For the water on the other side, only 10 milliliters is going to graduate center. Now, okay, you didn't really get your material. You need to get a paper towel. Is it anything mixed yet? So you're fine. Find your weight. Make sure that things are directly on the zero. What? Oh, I'm sorry. Yes.
That is
So you get your weight, yes. So now you can take your bands off, let it react. Was it back at zero?
the door. It's supposed to door. I'm just making sure.
You guys have any more? Okay, so it's balanced. That's 10, 15, 15.1, 15, like 15.3. Like that, observations that you want to make, you're on the same page.
Wait, is this all?
Make sure that.
No, actually, it's actually a real story. My mom, she dropped out. I was in her stomach. And she slipped on ice and then she got her back. You guys want to know how long it took to put her 24 hours. No, it was 24 hours. I was 2 weeks late and I was working like but it's real. Don't give me the picture. Born on March 19th, but I got out. And then they didn't know when I waited to take me out. Yeah. Yeah, so they were the 15-year security guard. So
They were gift for me? Okay, so now you're gonna mix it? You guys can put somebody can put materials in there.
you guys use me. That's what they do. I had to say,
Forgot you guys. So just compare it. Yeah. Alright, so you take a book section.
No, it was theirs.
No, it wasn't me.
He put 3 teeth.
Alright, let's do it first before it.
Sharina put 22.7. I swear,
It's like 21. I am gonna open it only because I told her to put a certain amount and
She wanted you.
she wanted to make sure it was 21.2.
my mom wants to
Okay. Make sure that when you're done and you made the observations, write down the 21.1 because I have to hold
She
it.
bought the strips and see what looked like
And then go ahead and answer the questions.
She put that right here, right? And she thought she was gonna
There's lots of it.
I was like, oh,
And then it should have.
I was like, oh, okay, do that. And she's like, oh wait, no.
That happens.
Something
Welcome to do it again.
She did like this. She did about this. It was like this. I'm like, I was like, you're supposed to put it like this.
No, but I can take that back.
I know, and she took it off like this. It's supposed to be like that.
You already got your green book, right?
You just, oh my god. It's like an emerald green with like air back.
And
Oh, you actually. How are you gonna do it? We just watch that shit.
It's really cool.
okay, we made sure that you had this tape receipt. Alright, what did you get for a week?
Oh my god, did you get some?
Your back looks a little bit small compared to others, so I don't know if we lost air or somewhere.
Miss, we lost air.
Oh,
That's okay. You guys gonna answer those post-like questions now?
Richard,
and you're on the post-lab questions. You should be working together as a group on the post-lab questions. Kayla, I'm speaking. There's one question on the back, so I don't want you to overlook that one. It's one question on the back, so answer your questions, get them done.
All of the votes, 17.
Yes. You think so?
That's dipped on me.
Yeah. Yeah, so that probably affects that's why everybody lost their mass. Okay?
And then I looked and
But that's okay, that happens. That happens, but that's what you're right about. You talk about, well, maybe, I don't know how accurate it is because I see water on my balance, which means that there was a loss of mass. Not due to the reaction. No. It's going too hard. There's other things there too, like there's a lot of accessory stuff. Anthony, I oversee a couple of things answered on that.
say that word, Sarah. Sarah with eyebrows.
So guys, you're only on that. You haven't even done the question yet. So just that's 2, 3, 4, and 5 based on that.
Yeah.
You have to do it online because the paper is up.
Me and Fidel, sit down. Hey, person.
I'm going to actually ask you to, Aya?
Yes.
Aya? I'm going to ask you without a sound to stand up and go back to your regular seats, even though you're not done with the questions. I'm going to ask you to stand up and go back to your class seats quietly without a sound. And I want you to finish working on the questions for the next 5 minutes. I'm going to give you 5 more minutes only. And I want you to work on them by yourself. 5 minutes by yourself. Zion, 5 minutes by yourself. Okay, go back to your seat. 5 minutes by yourself. Okay, everyone back to their regular seat. Except Max, come to the middle table. Okay, so 5 minutes. Anthony, turn around, go back to your table. 5 minutes by yourself.
There's one training today.
Compared to the one that we did the other day. We did them separate, so. But do your best to answer it, okay? We'll have a discussion about it anyway.
So, one was with disagree. Is anything added or removed besides like?
No, it doesn't belong on the table. It doesn't belong on the table. Sorry.
We don't need to gather all our stuff right now. Asha, you can stay over there. That's why I had Max go over here. So you weighed those cups, okay? And then you poured the water into 1 cup. So is anything added or removed technically? Anthony? Again, Jared, these now 3 minutes.
I'm just asking Max.
Okay, but right now, it should be silent, and we should be answering these questions. I'd like to have a little bit of a discussion before we leave, and then you're gonna revisit these a little bit more. So I want 2 more silent minutes.
I really forget everything.
Just do the best you
I don't know what to say.
can. Then just wait. Remember to keep in mind the experiment that we did the last time with the cups, where Zion and Ada talked about gas escaping, and they lost about 1.5 to 1.8 grams of mass in that first experiment. Compare that to the data that you have in this one and see how that compares. And then also, remember, as I walked around, some of you were saying, oh, mine was leaking, the bag was leaking a little bit. So keep in mind that all that stuff is part of the mass. So when you're making your conclusions, you want to keep that all in your thoughts. And there's a law, okay? There is a law that states, I'm assuming if your head's down, that means you're done, so you're just being patient, Zion? Okay. So, the law of conservation of mass. I'm going to read this to you. In a chemical reaction, such as the formation of water, there are the same number of atoms before and after the reaction. So this is a law. And I want you to think about, and I'd like actually everybody before you leave, because I don't think we're going to really have enough time to do a really true discussion. I'd rather save it for first thing tomorrow. On the bottom of the paper with your post-lab questions, can you copy down this law? And then I want you to think, go back and look at these questions again tonight, and I want you to think about how this law relates to these 2 experiments that we did. Okay, so copy it down, and then your homework tonight is to go back and look at these questions to prepare for our discussion tomorrow, so that we can have a good one. What? Under question 5, just maybe halfway down. Once you've copied it down, I should see you quietly putting your things away in your bag without getting out of your seat, just starting to pack up and get ready.
I didn't read your social studies.
Put that away, put everything in your bag. We will have a discussion tomorrow. Not at all.
I want to be recorded. We don't.
Okay, take out the lab sheet from yesterday. Post-lab questions. And this is what we're going to do. So yesterday, I showed you the definition at the very end of the lab. I showed you the definition of the law of conservation of mass. And then I had you write it down, okay? And then I asked you for homework to revisit those questions with this law in mind and make any changes necessary, okay? And I just want to make sure that you really have made some good thoughts. So I'd like you to take another maybe 2 minutes, that's it, to look over your answers and make sure that you have some quality answers there. At the end of 2 minutes, you're going to have an opportunity to share at your table, and then we're going to group share.
science and civics on this.
Okay, we are now at the point, as I told you yesterday, that I was going to have you, instead of pairing up, because I know we have tables of 3, it was getting awkward with the pairs, we're table pairing. So in some cases it's 3, some cases it's 2, and you're just gonna have a quick conversation about these questions. I want you to go through each question, so 2 through 5, and what your thoughts are on it, okay? Anthony, why don't we do this? Sharina and Cassidy, why don't you talk and Anthony can listen, since he doesn't have his materials with him, okay? And then you two can talk, all right? Yep, you're gonna be in trio, okay? No, you're just having a pair share, okay? So, I'm gonna give you about 3 to 5 minutes to share at your tables.
What's the point of having that three? Because I don't have my paper.
He doesn't have anything, so you pair up, they're pairing up, and he's just listening, okay? So everyone is sharing at their tables.
Wait, all of right?
Formation. There are the same atoms before and after.
I always have boron combined with boron, and when we combine them,
We're in the gas.
the mass change.
Well, that
What did you write?
The mass decrease when
What did you write?
what it is.
You don't have yours? Did you say for number 3?
The added.
We're mixing the cooks and notice that the mass is swimming.